on right now?
No.
Hello. Recording has been started. Section 2.2. So we're gonna do 2.2, then we're gonna jump up to 3.1, then we're gonna come back to 2.3. We'll talk about functions and relations here. We're gonna talk about functions versus function notation. What's function notation? What's the difference between what a function looks like in function notation, huh? F of x, right? So if I write f of x, that's not function notation, as opposed to y equals, right? We know that. So everyday phenomena involve two quantities. Mathematical term for such a rule is a relation. There is a relationship between the two. All functions are relations, right? Are all relations functions?
No.
Okay, so we're good there. Simple interest I earned on $1,000 for 1 year is related to the annual interest by the formula I equals PRT, right? The amount of interest you earn is equal to the principal amount times the interest rate times time, and in this case, time is 1. So in this case, since we know some of those variables, to calculate the amount of interest I earn on 1 year on $1,000, I would have to know what R is, right? You give me an R value, I'll give you an I value that goes with it. Okay. Simple relationship there. Oops, when you go back, I gotta scroll down. T. So I equals 1,000, huh?
What'd you just say?
TD.
That's a little.
You missed a D
A
when
little,
he wrote his name.
a little on the border there.
He missed the D when he spelled Teddy. You only put one D in it.
Don't worry, I've got two D's in it now.
Okay, 6. Okay. A function f from a set A to set B is a relation that assigns each element x exactly one element. So if there's a 1-to-1 relationship, for every x, there's only one y, that makes it a function, right? Domain is the x values, range are the y values. Domain is the input, range is the output. You've seen charts like this. I've got different times of day, I've got different temperatures. Each time of day, I've got a whole bunch of things that I could choose for my temperature, but each time of day only corresponds to exactly one temperature. Okay, so the temperature of 15 degrees Celsius repeats, is that okay?
Yes.
That's okay.
As long as
Yeah,
the
they're
X
three and
can't
four.
repeat, but that's the Y value. As long as the X doesn't go to 2 spots.
Yeah.
For instance, right now, outside, it cannot be 60 degrees and 80 degrees, can it?
Oh, okay. I don't.
It should be 70.
But it can't be 60 and 80 right now.
No.
No, that doesn't make sense, right? Maybe in 10 minutes, it'll go from 80 to 40, but
I mean, it is
Okay.
Texas.
4 ways to represent a function. We can talk about it verbally using a sentence. We can talk about it numerically using a list of ordered pairs. We can graph them, or we can do it algebraically with an equation. To determine whether a relation is a function, you must decide whether the input value is matched with exactly one output value. If it's matched with 2 or more, the relation is no longer a function.
There's more.
Hmm?
Oh, wait, there's more. I don't know, there's always something else. So yeah, I mean,
So determine whether the relation represents y as a function of x. Letter A. The input value x is the number of representatives from a state, and the output value y is the number of senators. Is that a function?
yes.
Why do you say yes?
Oh, no, never mind.
No,
there's two X's.
Because you can have two.
You're not looking at the table. We're looking at just letter A. This is 3 problems.
Oh,
We're looking at just A. The input value x is the number of representatives from a state, and the output value is y, the number of senators.
Yes,
Why do you say yes, it's a function?
because it's got an X and a Y and they're different variables.
Okay, so we need to work on our government classes or whatever,
well,
or social
the-
studies.
The representatives is based off the population, right?
Okay, and senators is,
Just like So-
Two. Right? So what is y gonna be for every value of x? Y is always gonna be two, because states only have two senators, right? So is A a function?
Yeah.
Y can only be two, right? There are no other options. Y is only two. So the output, I don't care how many representatives, I don't care what the X value you give me. 27. The answer is two. There's no other answer. Each state only has two senators, so this would be a function. It's kind of worded weird, but B, is B a function?
No, it's two.
Okay.
This one, two corresponds to 11. 10 and 11. That's the same. The way he talks to himself every time too is awesome.
No. Okay, part C, is it a function?
Yes.
Okay.
Vertical line test.
Passes the vertical line test. So A, we have a verbal description. B, we have a set of points. C, we have a graph. And so that's three different ways of talking about a function. Okay. Go back. Because I gotta go down. Okay, so here are the solutions. A was a verbal description. It doesn't care, I don't care what X is, Y is always two. The table's not a function because input value two is doubled, repeated. And the graph is a function, each input is matched with one Y value. If we have a set of points, if I just have points, this is called discrete. Okay, just a bunch of points, that's discrete. If I have a function, most of the times, like a polynomial function, such as the one shown, y equals x squared, that would be a continuous function. One way to think about discrete and continuous. I said a set of points is discrete. So I've got this point, this point, this point, this point, this point. Can anybody draw those 5 points without picking their pencil up? Is it possible?
No.
No, so it's discrete. Okay, if I was to draw y equals x squared, can you draw that parabola without picking your pencil up?
Yes.
That's continuous. So continuous, you can do it with one smooth thing without picking your pencil up. Okay, so know the difference between continuous and discrete. X is going to be the independent value. Your input is going to be independent. Your output is dependent.
Wait, is continuous gonna be like a straight line or a?
That's not a straight line.
No matter what.
It's just gonna be
Well, a
a
straight line, you don't pick your.
Okay,
Hand up.
so that's continuous.
Okay, so it's just gonna be like lines. Or forms of lines.
It's something that can be drawn without picking your pencil up. This is a continuous function. This is a continuous relation because that's not a function. Continuous. Discrete, because I cannot draw that with one pencil stroke. Okay, so I do have lines involved here, right? Okay, but because there's a break in there, that makes it discrete. Other questions? The domain of the function is a set of all values taken on by the independent variable x and the range is the y. And remember, those are alphabetical. Domain comes before range, just like x comes before y. Independent, and I'm just gonna take that y right there. Okay, dependent and y just happens to be there.
The range is right above one.
Yeah, range is.
Yeah, let me do it right. Domain and range, there we go. Domain is x, range is y. Thank you. When using an equation to represent a function, it's convenient to name the function for easy reference. Y equals 1 minus x squared is y as a function of x. We can change that to an f. So instead of having y equals 1 minus x squared, we change that to f of x. when you write it in function notation, you're saying, hey, this is a function, just because it's an f doesn't mean that's why I'm saying function, okay? Because g of x is also a function, right?
Yes.
Okay. This function depends on x is what this is saying. Okay, do you have a question?
No.
Okay. So the input value is x. I put that into the equation. The output is going to be f of x, or the result of plugging x into the equation. The symbol f of x is read as the value of f at x, or simply f of x. The symbol f of x corresponds to the y value. So you can write y equals f of x. They mean the same thing. And the function f of x equals 3 minus 2x. I can calculate f of -1, f of 0, f of 2. How would I find f of -1?
You plug in the -1 where all the X's are.
That's it. Okay, so f of -1 would be 5. -2 times -1 is +2, 3 + 2 is 5. F of 0 would be 3. F of 2 would be -1. Okay. So we got those values, 5, 3, and -1. It doesn't always have to be x. Okay, and it doesn't always have to be f either. So I could say f of t or g of s, it doesn't matter.
Is there a difference for the f of x and like the g of x? Or is it just the same?
Mhm. No. So if I was talking about, if I was gonna graph the time for a given day, or the temperature for a given day, I could say the temperature at a particular, maybe h for hour, so T of h. What does T represent? Temperature. H represents the hour. Okay,
So would you use f of x and g of x, like if you're graphing two functions?
I could graph T of h if I wanted to. Doesn't matter. If I was gonna graph T of h, which is on the horizontal. H is horizontal. Okay. And T is vertical. Yeah. Dependent is always on the x axis, or the horizontal axis. So basically, to calculate something, this could be anything, so they just put gray boxes there. That could be f of x is x squared minus 4x plus 7. That could be f of r is r squared minus 4r plus 7. So it doesn't really matter what it is. So remember piecewise functions.
Yes.
Okay, piecewise function is made up of
Oh, it's not.
pieces, hence piecewise, right? So here's a function. F of x is equal to x squared plus 1 when x is less than 0, but it's equal to x minus 1 when x is greater than or equal to 0. The question says, when x is -1 or 0 or 1, what's the corresponding value? So how would you calculate f of -1?
Or you can use
So
g
then
one.
the -1 would use.
I'll see a bunch of x's. Where are you gonna plug that -1? The top equation, because -1 is less than 0. So pay attention to what function you're plugging it into. Okay, so because x equals -1 is less than 0, we use f of x equals x squared plus 1 to obtain, plug it in, what are we gonna get? 2. F of -1 is -1 squared plus 1, and I'm gonna say this, I've said this, I'm gonna say it until I'm blue in the face. Make sure when you're plugging numbers in, you put it in parentheses. Okay, make sure to realize that -1 squared is not equal to -1 squared. So those are different, right?
Why did they use the like x squared plus 1 and x minus 1?
This piecewise function, the top part is the one we use when we have an input value less than 0.
Just for any equation?
For this piecewise function. So because -1 is less than 0, we plugged it into the top of it. Okay? for 0, that's equal. I'm recording, sir. Okay. 0. 0 is not less than 0, so I will not use the top function. 0 is equal to 0, so to plug 0 in, I would plug into this one. Okay. Plugging 0 in, I get. Okay. And which function would you plug 1 into? The last one. And you get 0. So what if the function looked like this? I want to know what G of 0 is.
Loves the D.
It's this. This needs to be replaced. Plastic will mess up the marker. So what is G of 0? Okay. Is 0 a part of the domain?
No.
Okay. This tells me my domain. My domain is from -infinity to 0, not including 0. 0 to infinity, not including 0, right? So G of 0 is undefined. Any other x value, is it defined? Yeah, it's defined on any other x value, but not 0, because 0 is not part of the domain for the G function. Any questions on that concept? Okay. And I believe the bottom is just working out the, yeah, we look at that. Plug in 0, and we're good to go. The domain of a function can be described explicitly, or it can be implied by looking at the equation. Folks, any equation you're looking at, any function, you're going to start with saying the domain is all real. That's where you start, always. I start off by saying the domain is all real. And then we look at it and say, okay, but are there any problems? Now, I don't have to tell you where the problems are. It's going to be implied. What can you not divide by? 0. So because I cannot divide by 0, I'll look at this function here. I see that my variable is in the denominator. I don't have to tell you what x can't be. You need to figure it out. Okay. What value or values of x would make the bottom 0? 2 or -2, because this factors into x plus 2 and x minus 2, right? So because this factors into x plus 2 and x minus 2, and you set those equal to 0, and here's how I would say this. I would say, okay, well, x squared minus 4, because I'm dividing, x squared minus 4 cannot equal 0. Does that make sense? Because as soon as x squared minus 4 equals 0, I'm dividing by 0 and it's a problem. So we factor that into x plus 2 times x minus 2 is not equal to 0, which means x plus 2 can equal 0, or x minus 2 can equal 0. And that's where this statement right here comes from. Okay. So what is the domain of this function? The domain is anything but 2 or -2, right? Or we could say the domain is -infinity to -2, union -2 to 2, union 2 to infinity. Okay. And that's written in what format? What's that called? This is interval notation. I could say x is equal to the set of numbers x such that x is not equal to 2 plus or minus 2. That would be set notation. And I'm just throwing that back out there. We've done it before, just throwing the review out there so you know what's going on. Okay, so the first thing you want to look at is, am I dividing by the variable? If so, I can't divide by 0. The other problem, in the real world, what can you not take the square root of? Negative numbers, right? So, and we're not gonna be messing with graphing imaginary stuff. We can, but we're not gonna do that, okay? So if I was wanting to graph this, I would just have to say, okay, well, hold on, I'm taking the square root of something. So when you're taking the square root, and they've actually said it right here, whatever is inside the radical, say, okay, I don't know about what x is, but I know that x has to be, because that's what's in the radical, x has to be greater than or equal to 0. And there's nothing to do here. There's nothing to solve. X is greater than or equal to 0. And so the interval notation would be from 0 to infinity, bracket on the 0, because yes, it can be 0. The square root of 0 is 0. Okay. So the domain of this function would be x is greater than or equal to 0, the interval from 0 including all the way to infinity, and so on. So denominator can't be 0. Radical has to be greater than or equal to 0. What if we have a radical in the denominator? Okay. It's going to be the same thing. We'll come back to it in a second. So let's look at some problems here. Finding the domain. Letter A. What is the domain of that function? Is it a function?
Yes.
I heard yes and no.
Yes.
Is A a function?
A is a function.
Yeah.
A is a function. For every x, there's only one y value. So A is a function. So what is the domain of that function?
Oh, it's just 2, 4.
Okay, they have to be listed specifically, don't they?
Yeah.
You can't say it's everything from -3 to 4, can you? Because you see a 3.5 up there? Okay, so the domain,
-3, -1, 0, 2.
-3, -1, 0, 2, and 4. Part B. What's the domain? Everything except -5. I'm dividing. So to find the domain, I look at it and say, well, okay, here's my problem. I know that x plus 5 cannot be 0. Therefore, x cannot be -5. And that's acceptable. What's the domain? X can't be -5. That's the domain. Okay. Part C, the volume of a sphere, V is equal to 4/3 pi r cubed. How many variables do you see in V equals 4/3 pi r cubed? 2, and they are V and R. Okay. What is the domain of this? R can be anything?
Is this like the actual formula for volume?
That is the volume of a sphere, yes. What is the domain? Think about it. Think about a sphere. You've got a sphere. What can the radius be? A sphere can't have a negative radius?
No.
Okay, anything else?
It can't be zero.
It can't be zero, because if the radius was zero, what do we have? We don't have okay, so here we go. What's the domain?
All real
Everything
numbers
greater than
greater
zero.
than zero.
R is greater than zero. That's it. Yeah, and what you said is correct. He said all real numbers greater than zero. Same thing. Okay. So sometimes you gotta think about the situation. Okay.
Never doing logic.
Logic, imagine that.
No math.
Letter D.
Big tie.
What would cause a problem in this one for the domain?
-3.
You can only take the square root of non-negative. I don't want to say positive because zero falls in there, right? Can you take the square root of zero? Okay, so because I'm taking the square root, I know that 4 minus 3x must be what? Greater than or equal to 0. Right? What's the question, Teddy?
I feel confused. You said, you don't want to say positive because zero falls into, is zero positive?
It's not. That's why I said that this has to be non-negative.
But it can't be zero.
It can be 0.
Oh, it can be zero.
Square root of zero is
Right,
zero.
I didn't even look at it.
Yeah, square root of 0 is 0. Solving this, first step.
Subtract 4.
Subtract 4, negative 3x greater than or equal to negative 4. Next step. Okay, anything important about dividing by negative 3?
What's the sign?
Okay, it's an inequality, so don't forget to flip that sign. Okay, so dividing by negative 3 gives me x is less than or equal to 4/3. I could write that as, it goes on to negative infinity, right? So negative infinity, comma, 4/3 bracket, right? Because it can equal 4/3. Questions so far? I believe the bottom just hasn't worked out.
This uses interval notation.
This one,
The
that's interval.
the unit,
Say that again.
like the whole unit we're doing right now is about interval notation.
You need to know them all. Here are the solutions. Domain, that's what we got. Part B, yeah, that's what we got. Part C, we're talking about a sphere, R has to be positive. That's what we got, next page. Part D, yeah. We talked about this already. 3C was talking about the sphere. Obviously, you can't have a sphere with no radius, and a sphere can't be negative. So apply common sense sometimes. Hopefully all the time.
Then the entire really fill this up. Oh, man, this one's gonna.
Okay, this is called the difference quotient. The difference quotient is very important in calculus. Okay, this is actually something used in calculating a derivative.
So we don't
know. But you need to understand what's going on here. So the difference quotient, I gave you some function. F of x equals, and we're gonna do one in a second. F of x equals x squared plus 3x minus 5. And I tell you, what is the difference quotient? You actually plug in x minus h. Then you plug in x. Combine those, that's what it says, subtract those because it's a difference quotient, and divide by h. Okay, and magical things happen. H can't be 0, right? Because if h was 0, you would have x plus 0, which is just x. So that would give us f of x minus f of x, which would be 0 divided by, can't divide by 0. not important for y'all right now, but 0 divided by 0 is called the indeterminate form. Okay.
What's the indeterminate form?
A function is a relationship between two variables such that each value of the independent value corresponds to exactly one value of the dependent value. And then here's several ways of saying some of the things there. Function notation wise equals f of x, same thing. F is the name of the function, y is the dependent variable, x is independent variable, f of x is the value at x.
Could you have a y function?
You want y equals, you want f of y equals,
Well, like,
it's probably not gonna be a function, but I could graph it. Difference quotients. Domain of a function is a set of all values of the independent variable for which the function is defined. If x is in the domain of f, then f is said to be defined at x. If x is not in the domain of f, then f is said to be undefined. The example I gave you with the piecewise function.
Are your slides different than yours?
Huh?
Are your slides different than the ones in the classroom? That was the last slide.
Oh, I'm actually doing the packet instead because the PowerPoint has had extra stuff. Okay. The example I did of the piecewise function a while ago, where I defined g of x, and I said, what is g of 0? I said g of 0 was undefined. G of 0 was undefined because 0 was not part of the domain. And that's what it's talking about right here. The range of a function is a set of all output values. The implied domain, we've talked about this already as well. If f is defined by an algebraic expression and the domain is not defined, then the implied domain consists of all real numbers for which it is defined. Okay, here is a problem where we will evaluate the difference quotient. And instead of uncovering it, let's just work through this. So if I give you a function, f of x is equal to x squared minus 4x plus 7, and I ask you to find the difference quotient, I'm telling you to calculate f of x plus h minus f of x over h. Be careful on the minus f of x. So pay attention to how I write this down. To calculate this, the first thing I need to do is figure out what f of x plus h is, which means I'm going to plug x plus h in for x. Are y'all following me there? Whatever is inside this f of right here, that needs to be in place of x. So I have x plus h squared minus 4 times x plus h plus 7. All I did was I took the function and I plugged in x plus h. Now I have to subtract the function. So I'm going to take all of that minus. Now, because I'm subtracting something that has multiple pieces, I need to make sure I group it. Folks, these parentheses are so important. If you miss these parentheses, you're going to miss the problem. Okay, I am subtracting parentheses x squared minus 4x plus 7. This is all divided by h. We now have to multiply everything out and combine like terms in the numerator. Okay, if I took x plus h and squared it, that would be x plus h times x plus h. So first times first. X squared. Outside times outside. XH, HX, whichever. Inside times inside. Last times last. Distribute to 4. Minus 4x minus 4h plus 7. Distribute the negative sign. Minus x squared plus 4x minus 7 all over h. We will now combine like terms in my numerator. If you did this correctly, some magical stuff's gonna happen and a lot of the stuff's gonna go away. Okay? Combine your x squares. What do you see? X squared minus x squared. What's that mean? Gone. Look at this one. I've got a minus 4x and a plus 4x. Gone. Plus 7, minus 7. Okay, look at what's left. What do all the terms that are left have in common? Okay, that's what's gonna happen here. So let's go ahead and I'm gonna write it. I'm gonna combine the like terms. I'm gonna write it down in descending power. So I've got h squared first, right? What's this? Plus 2 x h. What else do I have? All divided by h. So now that I've totally combined like terms, factor out of the top, I can factor an h out, correct? Factoring an h out, I'm left with
H plus 2x minus 4.
all divided by h. What happens to the h? H gets canceled. So my final answer is h plus 2x minus 4, but there's one more piece to this answer. And that piece is h cannot equal 0. Okay. So it started off real ugly and it cleaned up.
That's your answer?
That's the answer. Don't get in a hurry on these. Don't forget these parentheses. You see, if I didn't put the parentheses around it, I wouldn't have changed that to a plus 4x, right? Which meant I would have had a minus 4x and a minus 4x, which is, you got a problem, okay? Questions on this? Okay. Practice problems. Let's look through these and see if anything jumps out. Number 1, is that a function?
Yeah.
It should look familiar from last test. That equation should look familiar. It should remind you of something.
I think it's a function.
If I was to graph that, what's it look like?
Line.
No, it's linear.
It's just a line, like a horizontal line.
Because it's all of those can be, you can. Split all of those in this way.
What is that?
Circle standard form.
What is that?
Circle.
This is a circle. The center is at 0, 0 with a radius of 2.
Oh, 2.
Okay, so this is a circle. Let me ask you again. Is this a function?
No.
Okay. Guys, you gotta be able to recognize that. Okay? Not a function. No. It is a circle.
Is there a way you can graph a circle?
The only way to graph a circle on your calculator only graphs functions. What you could do is solve for y. And remember, when you solve for y, you're gonna have to take the square root. So you're gonna have a plus and a minus. So you're gonna have to graph one of them on the plus and the other will be a minus. But yeah, you can graph it, but it's gonna take 2 to graph it. Number 2, is that a function? I don't care what x can't be. Is it a function?
Yes.
Yes, it's a function. You give me any value for x, and I'm gonna give you one value for y. It's a square root function, folks. Okay, so yes, this is a function. Number 3, I can plug those into the appropriate equations, right?
Yes.
Number 4, domain. Oh, I'm dividing twice. So I've got 2 problems, don't I? What can x not be? X can't be 0 or
Or negative.
-5. Because 0 would make the first one dividing by 0, -5 would make the second one.
So if it's under just X, we just say it can't be 0. It can't equal 0.
Yeah.
Okay.
Because to solve that, you set the bottom to not equal 0. So that this one here, I would have actually had x plus 5 is not equal to 0. Subtract 5 from both sides, and that's what you get. Number 5, what's the problem? We have 2 problems, don't we? Okay, we have 2 problems. One problem is the square root of 6 minus x cannot be 0, because that's my denominator. Right? Set the denominator to 0, solve it. What's the other problem? What can you tell me about 6 minus x? What must it be? Non-negative. It can't be 0. It can be 0, right? So to solve this one, we know that x can't be 6. To solve this one, we know that x has to be less than or equal to 6. They kind of conflict each other, don't they?
Wait, why can't it be equal to 6?
You can correct the circle.
What's that?
Why can't it be 6?
Because 6 minus 6 is 0. Square root of 0 is 0.
So it'll never be 6.
It can't be 6 because then we're dividing by 0. Can't do that. Over here, it says it can be less than or equal to 6. So how do I make these 2 both happy at the same time? They both have to be happy. If I combine these, put them together,
X is less than 6.
x is less than 6. Okay? They have to both be happy. If x is less than 6, then it's not 6. If x is less than 6, then it's less than or equal to 6. They're both happy, right?
Oh, it's a minute left.
Can you go back? I know.
It's like it's an app that comes installed on like.
My name is